Okay, so today what we are going to talk about is list, which I already mentioned. Um, so let me first give you some introduction in this our familiar Blackboard, and then go into the details. Now, see, Python is actually, though it is used in many areas, data processing is one strong feature of Python. So the data structures, that built-in data structures or libraries they are much stronger and adaptable to any kind of data that can be manipulated with Python. Okay, that very easily. Okay, the interfaces are so intuitive and easy that you can manipulate any kind of data. So the reason is basically it's object oriented. Okay, and because of that it makes our life much easier. So going forward, at least for 2 3 classes, I am going to spend something on the data structures that Python supports. Then we will go into some other topics like maybe modules, packages, how to build those things we will talk about. Okay, now today's topic is lists. So before that, list is what sequence of some items. Okay, um, this is the um, indication, the symbols used for mentioning a list. It can have list of items. Now this is handled in a different way here in Python, and mostly, even if you are writing your own list in C, you might have done the similar way. Okay, managing your list and manipulating some functions to operate on list, all that you would have done, okay, in your data structure course, or you may be doing it now. So now there are list means is a sequence of items. Okay, so there are so many other data structures which are also there. I will go to the slides and then summarize them, and then come back and show you some examples of simple things. Then we'll start off with what are the operations that we can perform on list. Okay, so let us start with some introduction. So what we are going to see is a collection or containers in Python. Okay, a list also is like a container which you can put some items into it, and it has that, or is a collection of items. Okay, so there are some basic sequence operations. Whenever you have sequences of data, what all operations you can perform? Maybe you can add something, you can remove something, you can insert something. These are the basic operations, or search for something. Okay, these are the basic thing, or maybe look for some item or extract something out of it, those kind of things. And then what are the library functions supported for list specifically? Then comprehension in the list. Okay, this is some form of a shorthand notation to access the list, manipulate the list, or generate the list. Okay, you can generate a list of list items. Okay, using these comprehensions. This is one way of doing it. So let us look at that also. Maybe this portion we will do it after the break. Okay, after this, then I will give you a couple of homework which you can do. Then in the next class maybe we can look at the solution. Okay, maybe you can share your solutions with me through email, or I can open a assignment. I don't know whether okay, tomorrow time limit is there. Okay, you no, not there, sorry. You don't need to do it today itself. I know you will be dead tired by the end of the day, but you can do it tomorrow. I will maybe open a entry for you to put your homework solutions. So I want to see different solutions that coming from you. Based on that, maybe I can suggest something in the next class, which we have tomorrow. So we can maybe take it for reviewing your implementations, and then I will show you my implementation of this homework, and we will see that. Okay, so I will create an entry in the LMS which you can use it for submitting it. Like assignment, I will keep it. Whether we need to evaluate it, give some marks, I can decide later on. But it doesn't matter whether I am evaluating or not. Please work on it and then give me by tomorrow, end of the 5 o'clock or something, 5 p.m., 6 p.m. before the class starts, other classes start. Then our class will be at 8 or 9, I don't know. Okay, Wednesday. We will look at that solutions tomorrow. Okay, fine. Now, collection or a container is a compound data type because it's not a single data type. It's not like int array. Okay, int array is also a collection of integers, but it says that all the elements are of type int. Okay, here we are saying compound data types. It's not like a structure where you can have different element data types in it, but here a list is also similar to an array, but it can have different data elements. Okay, so it's a compound data type. There are basically 4 collection data types in Python. List is one of them. Let us understand each of them. Ordered. Okay, it preserves the order. If you are inserting it, it preserves the order in which the items have come into it. Okay, or if you are removing something, then still the order is maintained. That element is removed and then the rest of it is again like a number of persons standing in the queue. Ordered is fine. Once we say something is ordered, then it can be indexed, because only if all of you are standing like this, I can say that, okay, the first person please come out or raise your hand, or the third person please wave your hand. So only if it is ordered, I will be able to address you with respect to the index. Okay, or ordered data items only can be referenced using an index. Otherwise, I cannot say today, no, now it will be 0, the element will be this, but after some manipulation, maybe if it is required that it should be gone. But even if you are not doing anything with this element, if 0th element is different next time, then it is not ordered list. Okay, it's not maintained in an order. So indexing is possible only when there is an ordered list or ordered items in a collection. Now, another one is mutable. You know that string also has a characters which is ordered. Okay, it will be A, B, C, D is an ordered list of characters or sequence of characters, but it's immutable. Okay, you cannot change it. Whereas list is mutable, so that means I can remove A and then make it capital. Okay, so these are the 3 properties, basic properties of list. And then it allows you having a duplicate elements. I can have duplicate elements and also collection of different objects. It need not be, sorry, I have not mentioned it in this bullet. It need not be same type. You can see that they are all of different type. Now, I have a question. You can come on the mic and tell me what is this label pointing at, and what is stored. Okay, this is a list object. Okay, naturally it's a list object. What is really stored into this list? What are the entries inside them? I know there are all some integers, objects, floating point object, function object, string, but what exactly really, if you are looking into it and then if you are trying to understand the individual content of this list, what would you see in each of them?
A pointer to objects, particular integer string.
Objects.
Okay, I am getting 2 answers, or you can say that I meant only this. Objects, other one is pointer to objects. This is one answer, this is second answer. Is there anyone saying that I am going with 1, or somebody saying that no, 2 is not correct? Can someone tell, or there is a third option also available? You can tell me. Anyone other than those 2 who gave me the answer? Okay, I hope only there's 2 answers. Now, okay, let us understand this answer first before we go into this second one. If we say it's objects, that means what? We need to construct the object somewhere and then keep it suppose this object take, like we saw that string object takes 50 bytes, 51 bytes, 52 bytes. So we need to store all the 52 bytes here, and then another object takes 100 bytes. Maybe you should store 100 bytes here. Okay, so since this is an ordered list similar to our index integer array, maybe you need to have a byte array which is arranged like this, because it is indexed, so I should be able to access one or the other. But what if I need to change it, because this list is also mutable, then I should be able to remove something, add something, okay, change something. If I change something, I'm sure this object size is going to increase. Suppose if I have a string with the a, and then I say that string has to be changed to AB, now this 50 bytes will not be 50 bytes. Maybe yesterday you saw that it becomes 51 bytes. Then what happens if I am keeping it in the sequence in the byte array? It is going to not going to be maintained in the same like an integer array. So I need to rearrange the whole thing. If I make one change here, I need to disturb the whole setup, rewrite this in a byte array or whatever, because if you need to store the objects as such in a list, we need to do all this, okay, because it is indexed as well as ordered. At the same time, it is mutable also, please remember. So this implementation is one way of doing it, I'm not denying it, but this implementation is not the efficient one, and we shouldn't be doing this. Then what is the next one? Yeah, this is the right option. Do not try to keep your actual objects in the list. Keep the pointer to the objects or a references to the object. Okay, maybe in the C++ world we call it as reference. There in C++ pointer is also there, reference is also there. The difference is references cannot be touched. That sense you cannot modify them, and a reference in a C++ world cannot be uninitialized. If you are creating a reference variable like int ampersand, it has to be initialized with some address. So C++ has come up with a new name for the address with some security features, that you have a dangling pointer in C, dangling pointer or an uninitialized pointer, which is having a location int star IP which is not initialized, or maybe it is 0, which is pointing to some 0 location or null character. Null may be a good option, but if you are having an uninitialized pointer, it is going to point to something which is maybe not accessible to the process. So it can actually lead to crashes. But references in C++ is an improvement over pointer, wherein you can only declare a reference, some arf, only if it is initialized with some valid address of particular type. If you are int ampersand, then you have to initialize with the address of an integer variable. So similar to that, whatever references we call, we may have to call it as a reference if you are coming from C++ world, even in Python, because these pointers are already initialized. Okay, you cannot have a label which is not initialized with some address. But I told you that in Python everything is object, so whatever you are manipulating, all the labels, variables, everything is actually pointing at some address where the objects are residing. So what I'm trying to tell you, the list is going to have only the references to the objects. Maybe I will change it from pointer to object to reference to object, because it makes sense that you cannot have a dangling pointer or something like that. They need to be pointing at some valid object in the object memory. Okay, fine. Now what is the advantage? Okay, I need to tell you what is the advantage of holding only the references to the objects in your list. Imagine this is a immutable integer object. Okay, immutable integer object. If I am taking that value, maybe accessing it as 0, my list accessing it as 0 and then making it as 2, what am I doing? Actually, I am replacing the reference which was pointing to the object which is holding 1 to a reference which is having an object value of 2, which is already there. Okay, we have already a value 2 which is also pointing to the same object. So I may have the same reference pointer which is initialized to, which is the first element in the a list. So I may replace it with the another reference to the object 2. Similarly, if I am replacing this pointer will be changing, this reference will be changing. Similarly, the string also, if I am changing, it will be a new reference. But I am still maintaining the order, and the data structure inside that to maintain this my list in my Python implementation, I can manipulate it very easily if I am holding a references to the objects than the actual objects. Okay, I hope the idea is clear, and it's efficient and reliable and easy to manipulate when you need to do many operations on this mutable list object. Okay, fine. Any questions? Please stop me. Now, what is a tuple? Now, tuple is indicated with the parenthesis. Now, you know that parenthesis is used in another place, which is for functions to pass parameters. Similarly, tuple also is some list of items. Okay, sequences of items. I should not say list of items because list is different. So, sequence of some objects. Again, instead of items, I can say objects. Now, how will you differentiate between whether this is are you referring to a function or a list? Maybe I may, once you start writing the code, you will know that you will have a colon here to indicate that you are defining a function. And then when you are calling a function, you will be passing the parameter. Okay, there is no semicolon, but that's normally we tend to do that. So when you are calling it based on the label, whether it's a function object or it is a tuple, okay, tuple will be equal to this. So it will be resolving it. The compiler will be resolving it. Maybe when we are writing the code for tuple, we will see how it is the compiler of Python not getting confused whether a function is with a parameter is shown or a tuple with items are shown. How is it resolving it? Let us see that when we write a code. In this place, this is one piece of code I have written. My tuple with a list of something. Here also you can see that different objects can be there, and I'm sure you are very clear now that references are only stored there. Now, what is the difference between these two? Okay, ordered, indexed, mutable, immutable. Okay, that's the difference. Rest of it is same. It can also hold different types of objects, need not be same type. So data types can be different, and it is also indexed because it's ordered. But tuple is immutable and list is mutable. Okay, so that's a summary of these two. We will look into it maybe later on in the next class or something. This is similar to string. It is also immutable. Okay, now what are the sequences? Sequences are ordered collections. Okay, we always call sequence as an ordered collection. Okay, otherwise containers. Okay, we will say containers or ordered collection is different from the one which is not ordered. So strings, lists, and tuples are ordered collections. Out of them, there is a difference. These two are immutable. This is sorry. I should clear it. This one is immutable. This is also immutable. This is mutable. Okay, that's the difference. Okay, so strings and tuples are immutable and list is mutable. Okay, fine. But both are sequence. All three of them are sequences. Now there is one more collection which is a set. Now, if you see that one more common feature of these two are both of them can have duplicate entries, whereas set has no duplicate. Okay, there can be only one. Everything is unique. So when you are adding something, the library takes care that you don't add a duplicate entry here. And again, all of them are references. Please remember, somehow it has to refer. See, if it needs to find out whether a set is having a duplicate item or not, the library of implementing some adding the element or only adding the element, okay, needs to take care of what those existing objects are pointing at, what type of them, and what the value of them, and then what is the new item coming in, and if a string is coming and already you have a string, what is whether they are same or not. So they need to check whether they point at the same value or not, then they need to give a proper error. But you may have a string with the value of 2, but you may have an integer object with the value of 2. They are different because their data types are different. This is string object, this is a integer object. So it will be allowed. Okay, it will not go across the types and then check it. Okay, we can verify that. So that's a set. Okay, and one more uniqueness is unordered. It is not ordered in a, so if it is not ordered, then it cannot be indexed. So unordered and unindexed, but no duplicate element. So why did they come up with different collections? Because based on your application, you may have to choose one of them which is efficient for your usage. Okay, so that's why there are different supports provided. And you can also see the smartness of our Python designer. Our normal C uses this flower bracket for encode, keeping the collection of the instructions. Now, because this is freed up of this requirement, because the tabs are given for showing you the collection of code element or instructions, we are free to use this for defining some new data sets. Okay, built-in data types or data structures, and efficiently we are using the existing characters or symbols in the language. So that's the beauty of this language, wherein some freedom you got because you are not using this for a very mundane collection of instructions and then using it for this purpose. And then moreover, you are also avoiding the instructions being not written in a proper way by insisting on the tabs in between, so that the structured code is also achieved, and then you are freeing up the symbols also, so that you can use it for various purposes, and which is being shown here. Okay, we will see each of them separately. Okay, don't think that this is going to be the final introduction to this data type, but I thought I will spend a little more time so that you understand the differences of all this. Now, what about dictionary? Dictionary always comes in pairs, key, value. Okay, the first element is a key, and always the dictionary is searched with respect to the key, and then if it is found, its value is returned. Okay, similar to our English dictionary and the dictionary, this what is this value corresponds to what value it actually refers to. So key and value pair, always it is a pair of elements. Okay, and collection of pairs is naturally, and it is unordered because you are searching with respect to key, you are not searching with respect to any index. Okay, you are searching, looking for a particular key, and then you will find a value, pass it out. Okay, now is it immutable? No, it's changeable. Okay, you can modify it, and indexed also. Okay, we see it's unordered and indexed. We'll see how it is done. Okay, because we have a key, we can index it using key. Okay, we will not be using the ordered list item. Okay, we will not say that the 0th element or first element or something because it's unordered, but we can index it using key. That's why it is because we have another way of approaching a particular element or accessing a particular element. We have a indexing available, whereas here there are only data items are there, and we cannot do an indexing if it is unordered. Okay, so I hope you understand the difference, why even though if it is unordered we are able to index it, because of the presence of the key, and we are going to look for a particular item in the dictionary only based on the key and not based on any position or index or anything. Okay, so and one more thing is, like our set, this also no duplicate is allowed. You cannot have a key 1 saying that value 1 and then key 1 again a value 2. You cannot have it. Okay, maybe dictionaries may have synonyms saying that for a particular element these are the different words in the other language or even in English, synonyms are there, but this dictionary is different from that. Okay, you will have one key, one value pair, so you have to manage it in another way. If you want to have a suppose you want to say that one synonym you want to say for a verb and refer to multiple things, you have to have a list of things to say that these are the different meanings of a particular key. Okay, so don't think that when I say val1 has to be one value. It can be a another dictionary, or it could be another list, or it could be anything. So you are not limited by only one, it could be many. Similarly, one more thing also remember, a list can contain another list. A list can contain another list. Okay, that we will see today. Okay, fine. Now we will see something more detailed later on about individually. When choosing a collection type, it is useful to understand the properties of each type to make a right choice based on the need and properties of each. Okay, all these different types have consistent interfaces. All of them have consistent interfaces. So once you remember one, you can try it out on other things, and then it may work mostly. Okay, so that language is easy to pick up. Now, what are the sequence operations? I will show you, but I will we can try it out. Okay, writing program, and then we'll try it out. Or I can show you the complete code, and then we will see each one of them instead of typing everything, which may be boring for you. See, we can go into the particular sequence. Now I am saying sequence, that means it can be a string or a tuple or a list. Okay, and then we will be able to take out one element by element by saying x in s. And here we are not going through the thing. Here we are saying whether a particular element is there or not. True if the object x is in the sequence s. Okay, then it returns true, x is in s. So that means it is going to go into the list and search for that, and the first occurrence of that, which will be saying, based on that it will say that yeah, x is available in the list or a string. Okay, you can look for a particular character in a string, or you can look for a particular object in a list. Okay, and if it is not, then it will be returning a true if the item is not found. So that kind of thing is there. Concatenate operations of two sequences there. And multiplication, this is like create a sequence yes n times. So if suppose you have AA, if you say 2 star into 2, that means AA. Okay, you will be creating it twice. If it is 3 into 3, you will create AA. So this kind of data you can create it using this. And then accessing a particular element in the sequence, we saw yesterday the slicing. So same thing is available here also. Like string, you can do a slicing. You can also do a slicing on any of the sequences. I is inclusive and j is exclusive, and you can have a step value. Default is 1, but you can, similar to whatever we saw in the string, you can do the same thing here, because string also is here. Okay, you can actually string also, you can do all these operations using the string. On the string also you can do all of them, which we did yesterday. Length of a string we did. And then you can also pass one element which happens to be in the sequence and get the index where exactly, because I am saying it is a sequence which is ordered. Okay, then you can get an index out of it. So you can look for that particular element, and then which index it is, you can always find it. And if you want to know the count of how many, because duplicate is allowed, I said that duplicate is allowed. So you can find how many elements of this type is there. This exactly this object is there, not type, this object, whatever may be the object. How many copies of this is already there. Suppose you have a list with 2, 2, 3, okay, 4. Then if you say I want to do a count of 2, then it will return 2. There are 2 entries with the value 2. Okay, so count. This is different from length. Length is number of elements in the sequence. This is number of this particular object in the sequence. So they are different. And then which is the minimum value and what is the maximum, smallest or largest element in the sequence. Now again it depends on how you are implementing it. Okay, if it is of same type, maybe you can do that, but more or less it will try to compare the different elements in the list and then try to give you sequence. It will give you based on the type of object it is checking on. So similar to array indices in C, here also the 0 to n minus 1 is the index if there are any elements there. Okay, this is how they are accessed. Okay, so and then it allows positive and negative indexing, which I mentioned that we can have a -1 and then step is -1 and it will start from the back of the list. From the end of the list it will go and scan it. So you can do the same thing in the list also. Okay, fine. Now let me talk about the list and then we'll go into the some program. Collection data types can hold many different data items at once. Okay, collection means it can have many data items at once. All collections are built-in and mutable. Okay, I am talking about list. Okay, this is you need to relate it to the list only. I'm not generalizing it. Collections don't store the actual data items in them. They only keep the references to them. That's what I told you. List can have references to the objects of different types. I mentioned it. Each list can hold 0 or more references to the data item. So you can also have a null list. I can create a list with nothing. But do not think that if I have a my list with no item, don't think that it is not occupying any memory. There is already a list object is created with no item in it. Okay, so my list of length of my list will give you 0. Okay, and if you try to do any 0 or indexing into this, it is going to give you an error because it doesn't have anything. But do not think that null list will have no memory. Okay, similar to our string we saw null string. Null string also was okay. Let me not put a gap here. Null string also takes some space. We saw them 51, I think. So that many bytes it takes. So similarly, null list also may take some bytes. You can get the size of that. Okay, so you can have 0 or more references to the data items inside a list. List can also hold sequences of other types too. That means it can have other lists or tuples or sets or dictionaries and so on. So they can contain anything. Okay, it can have another list or tuple, or it can have a dictionary, anything. Okay, you can put anything into it. List can also be passed as argument. Remember, as I mentioned, everything is a pointer, right? Even the list object having different references to the objects is a reference again. So I can pass an entire list into a function, which is not very time consuming in terms of passing it, because it is not copying the whole thing into the stack or something. It only passes the address. So everything what is getting passed across in a Python in a parameter, okay, everything is a reference. Nothing is by value. Okay, so because of that, efficiency is there, but there are some problems also because you are not actually manipulating the values. So you need to always access the memory to get them. Maybe the compiler will take care of optimizing it, but what you are passing in the Python world is always a reference. Okay, not a value. Individual values can also be replaced because they are mutable. Okay, we saw that. Okay, you can replace it. So this is all about at a high level what all things can be done in a list. Now what are the library functions we have? Okay, let us see them. We have length, similar to what we saw. Append is, if you have a list, I say that it is ordered. If you are appending it, you are appending it at the end. So you are adding to the end of the things. Okay. Extend. If suppose you are adding two lists, append means you are adding an item into this. If you are extending the list, this is L1, this is L2, you are just connecting them. Okay, one individual list of items. Okay, whatever is there in L2 are copied into this, and then a bigger list is made. Insert n comma y. Okay, where is it? N comma y is insert an object y into the list x before the position n. So whatever is the index before that, you add it. Okay, you insert it, because you remember always it is a ordered items, data items. Now, what is pop? Remove and return the first object in the list. Now, when you pop it out, that object is removed from the list, and then the reference to that object, first object, okay, is returned. So, if you see in the push and pop world, okay, what we say is lost whichever was LIFO. In the stack we will be pushing it like this. Pop will pop out whatever was the last value which we entered. Here it says that it removes the first element from the list, okay, popping it. Okay, it's not same as what you see in a stack operation. Remove and return the object at a position n. If you are looking for a particular position, then you can pass n. Okay, then if this n is a valid index into the sequence, then you can pop it out. Okay, list. Okay, we can pop out that particular element, then it will be removed from there, and then that object will be returned back to you. Count of y, how many times this particular object is available, similar object of this type y, in the sense the same content. Okay, and then sort them. Suppose if you have a sortable, you need to provide a function also to sorting it, because you may have your own objects inside. Then you can provide your own sort function to sort them in an order. In place means you are not creating a new list. Okay, in the same list you are sorting it out. So what, you are not creating a new list. Okay, before sorting and after sorting, you will see that the same object x, you will have the list will have modified ordered. The order will be already modified, but you will have in the same address the content will be modified. Okay, the list object value is not changed. Returns a sorted version of x, does not change x. Here what is done is it doesn't change the x, it creates a new object, and then it doesn't change the x, but it gives you a sorted new list it formed, creates, and then gives you back. Okay, we will see later on using them. Okay, reverse is in place reversing. So you can see that the way it is invoked is different. Okay, if it is sorted and x, that means what is returned is a new list which is sorted, but the original x is not modified. That means the list with this ordering is not modified. You get a new order based on whatever logic that sorting is done. Okay, so I will not go further. Comprehension is later on. Let me see if there are any questions so far. Nothing.
Excuse me, sir.
Yeah, go ahead.
Sir, in slicing, I tried passing variables in that, means in that colons we give 1 2, that instead of that I am giving 1 a and b, then it's giving me error.
Okay.
It's saying that you should only pass integers there.
Yeah, that's a okay. Let us try that. A equal to 1, b equal to 2. Now I need to have a string, so my string okay. Now you want to slice it, maybe
Yes.
print my str. If I say this, you know that it will print everything. Now if I say a, working right?
So for me it gave error.
Most probably I don't know whether the version what you have is same.
Yes. So, but I was working with dataset, not string.
Okay. But okay, it should be acceptable there also if it accepts here. Okay. maybe you can send me the
Yes, sir. I will send the code.
code later on. Okay,
Yes.
fine. That's a good point. So let me. It's a good. So we will show you see B here. So that it's really working, and all the places it is working. And okay, fine. I think maybe we'll have C equal to 6. Okay, so it works in all the places. No problem. Looks like some other problem may be there when you tried. Okay, fine. Now let us. I also want to talk about strings only. So what is the time now? Okay. Um, when do you want a break? We have another 1 hour to. Can I take? Maybe I will do one thing. Can I take 10 minutes and then before I start list we will get. I think mostly I am doing. It will take another 5 minutes, 10 minutes. Because it's too early to break. So I will break you at 7 o'clock. Sorry, what I mean? 8 o'clock or 7. Sorry. Okay, so now let me try out something on the string. Okay, something which I have not done. I will try that today. Then we will break. Okay. A B B C C D D. E E F F G G H H. Okay. Now I want to try out those functions which I mentioned. Where is it? This one. Okay. So I want to use this. Okay, X in S. Okay. So how do I use it? Now if AA in my string print okay, so yes. Mm, okay, so it makes sense. Okay, so this is easy. uh, Multiplication, you want to do something, new string. Okay, uh, yeah, new string I will say equal to my string into 2, since we need to give a space around the percentage. So let me give always. I should do what I preach. Okay, so you can see that exactly this is multiplied, added twice. Okay, so that is working. And then plus we already seen. Indexing mostly we have seen all of them. Maybe count, length we have seen. So maybe count we can see, print count of where is that? Yeah, count, you need to invoke it with respect to the object. So str1 dot count. What are you counting on? Okay, what are you counting for? A. I'm looking for A. 2 of them are there. Yes, my string has only 2 A's. So count is working. And then min and max. Okay, let us see how min and max work. Copy. So how do you remember what is called how? This little bit invocation is something. Suppose if you need to pass something to the parameter, okay, something into the function, you will normally have the class, the object name and the method, okay, because you are passing something to compare it with something. Parameter is there, but if you do not have any parameter, mostly you are taking something understanding about the data structure, then you may have invocation like this, okay. So it is a little bit easy and you don't have to okay. Now let us see how min and max work. So this is very easy, A and D. So you can try it out on different list objects of different type and then see how it works. Now what is the time? 53 only, so we can maybe create a list also now, okay, till 7 o'clock. We'll go on. Now let me start off with some list, num list. Let me write it. Okay, so I'm going to manipulate this num list, sorry, dot append. See, again, you will call with respect to the object if you need to pass something to it, so it's very intuitive. Now you want to add a value like this, 8. Now you know that append will be adding it to the end, so print num list. Okay, now can someone tell me how does the print work? You can see that it is printing it based on what is being passed. It is printing, without even telling it. In printf we need to say percentage f, percentage d, otherwise that guy will get confused, right? It doesn't know what it is getting. Why is it not required in our Python print? Can someone tell me?
Not got it your question.
Sorry?
Not got it your question.
Okay. What I'm saying is, you can see the print of whatever you are passing. Sometime you are passing an integer, sometime you are passing a string. Here we passed a string, here we passed a list. And a string means it is printing it like this, okay, whatever the string contains. It is not putting a double quote. But for a list, it is covering it with it knows, the print is aware that it's a list. So, but we are not adding any other parameter to it saying that I am passing a list. Okay, I'm not saying type of type is like list, something like that. We are not passing it. Okay, how does the print know what is coming in? How does it know the type of this? Anybody? Make a guess.
String representation. There are two representations in the Python: the string and program representation.
I'm not able to understand what you're saying. Please, can you come again?
So there are two type of presentation in the Python: the string presentation or
Yeah, what I want to know is how does the print function. So suppose print is also a library, right? Suppose if I ask you to implement a print, you need to now have a logic. I may be getting an object of any type. I still need to understand the type and print it according to the type that I have. Okay, so can you tell me how it is able to do that? There is something which is built into the Python's implementation that it is possible to do it, but I want you to think about it because you should also be aware of that. How is it able to identify what type of object coming in?
I think print did not check the type. It directly print.
Yeah, actually, okay. I don't know whether you are telling me the thing. What? See, suppose if I say type, okay. type of num list. Okay. Oh, sorry, what did I do? Oh, okay. So what I'm trying to do is, okay, now I say type, it says class type, right? List. So actually I am passing, even for the type function, I am passing a reference to the num list object. Actually the object implementer has the information about what type of object it is. It has the information whether it's a list or a dictionary or an integer. So and it needs to be, see, let me tell you, it is not very easy. Okay. When you have an object, what you are getting is a reference. Okay. It's a address, or specifically some address of object. Now in a specific location within the object, within some offset, the Python implementation should take care that the type of that object type, okay, some enum or whatever, okay, you call it, should be stored there, so that any method which is getting a reference to an object knows what type of object it is getting. Based on that, it has to interpret the remaining portion. So it is similar to our malloc. When it is freeing something, okay, you are freeing malloc some address pointer. Okay, how does it know the free routine? How does it know how much it has to free? That information has to be captured in the address what you are passing. Okay, think about it. malloc, after you allocate some 20 bytes, it is returning you a pointer which is white star, and then when you free it, wherever you have copied this PTR, you are passing it as a free PTR. You are not telling how many bytes, whether 20 bytes have to be freed or 200 bytes have to be freed. You are only passing the address. What this address is what the user has manipulated. It has some 20 values, 20 bytes are given to you, and you manipulated it, you modified it, used it, and then you are passing the same address back, and the free routine is able to release 20 bytes back to the library, to the pool of memory. How is it doing? Because this pointer has something information about how many bytes I got it from the originally from the library, and that needs to be released. So that information is somewhere captured there. Similar to that, here when I say object you are passing, it has the information about what type of object it is, and you are able to the library function is able to release it or use it, access it, modify it, manipulate it. So that's the answer. Okay, I don't know whether you guys got what I am expecting from you. It's okay. Okay, I am exceeded the limit of exactly 7 o'clock. I am always on time. Okay, we will meet at 7:10. Shall we start?
Yes, sir.
Okay, now where are we? We will write some few. We'll try out something. Now append we saw. Now what else we can see? Extend maybe. Okay, sorry. Yeah, extend we will do. So I want to add another list which is having, already I have added 8. So 9, no, didn't I do? Append 8 I have done. So 9, 10, 11. Now I want to extend this list. So what I do, num list dot extend it with this add list. Now print. So let me number them so that you will know which print is what. At least from the list onwards, I'll start numbering them. Otherwise it is difficult. This I will print it above. So go. Now I want to second one, num list. I added it. Now 9, 10, 11. Now I want to check whether add list is different or modified or not. Now can someone tell me whether do you expect this add list to be changed, or will it be untouched?
Modified.
You think it is modified? Okay, sorry, it's not. So what is happening? um, I said it's mutable doesn't mean that when we are adding it as a parameter to something that it needs to be changed. Here we are changing this num list, okay, uh, with the new value which we saw here, but add list is not disturbed. Okay, so um, at least this is how it is good. Actually, we don't have to change it. Okay, now let me do one thing. Extend we have done, then let us do an insert. Okay, now I want to do num list dot insert. If you remember what is the syntax of that, insert is before this index, okay, position n and new object. So let me say, suppose if I say 0 comma 0, so what will happen? Now let us print it. Zero is added. Before 0 I said, but still because it is not there, there is nothing before 0, you cannot add it. So it has added a 0th element, okay, as the first element, as a first element it has added. Now let us see if I want to add it at the end. Okay, what do I do? So copy, insert. I want to find I don't know how many elements are there, so let me take it from here. Now this is going to return me whatever is the number of elements, but index is going to be one more than what it actually has. So I need to subtract it by 1 if I want to do that, but actually it is a before, right? So even if I don't subtract it, it will be fine. Now 11 is there, so let me add a 12 here. Okay, now let me tell you what I'm doing. Length I have taken. Okay, length of this num list is how many elements are there. Okay, it will be 12 elements, 0 to 11. So I'm passing 12 comma 12. Now as per the insert function, it is before the 12, index of 12, before the index of 12 is 11, or no, it is here, okay, at the end of the index, and it adds this element there. Okay, so you get the last element is added now. Now what if I exceed the range? Okay, let us try that. What if I don't give it within the range? Suppose I say index I want 100. Okay, what do you expect to happen? Now maybe this value I will say 100. Whatever is the length, add a 100th element to this. But here actually you have only this much of element there. If you index it, if you say that I want to add beyond the 100, one option is to introduce some null numbers and then add them at the end, which is not correct because you don't know what to put it in those in between places. So what happens is it just ignores what you want, it will add it to the end. Okay, it is like our slicing, where if you exceed the limit in the slicing also, it doesn't create a out of range error, but it quietly accepts it and then adds it at the end. So these are all the places where you are likely to make mistake. You may be thinking that you are adding a 100th element, but you are adding actually a 13th, 14th element or whatever. Okay, so you need to be careful in that case. When you are doing it, you are not actually adding a 100th element. It is whatever is the maximum it will be. Now let us see whether I can modify it. I said that it is mutable, so let us try trying it out. How do you test it? Let me, 0th element, I don't like 0 being there, so let me write some minus 100. Okay, and then let us print it. So it is modified. Okay, in the same object, link object, and that 0th element is modified. No issues, it's very easy. Now I want to do something, create a copy. Okay, if suppose if I do new num list equal to num list, now what do you think is happening here? Maybe I'll print it, no problem. So we are getting the same value. My question here is, has it created a new list here, or is it the same label pointing at the same old list, which is a num list?
Same label, sir.
Yeah, only one copy of the list is there. We have only given a new name to it, like an alias. It's like a file alias you have in the Unix world, soft copy or soft link. So it is creating a link to the same object which is there. So this is a good example of a shallow copy. So here is also a problem that you are likely to make mistake thinking that I have created a two new list, and then you may think that, oh, I can manipulate this without affecting the num list, which is going to be a problem. Okay, so you need to be very careful that you are not actually creating a new list here. Okay, now what are the ways to create ways to do a deep copy? Deep copy means create a new object itself. Okay, deep copy. We don't do a shallow copy like this, which is just a label we are changing, different another label is pointing to the same object, but we want to do a deep copy. There are many ways, not too many ways, very. So let me now real new num list 1. Okay, real copy. Okay, new list. What I do, num list column. Okay, before that, let us see whether what I claim to be a shallow copy is true or not. Okay, I have not tried it. It's not fair to claim without even trying out. So I did not do that. So let us verify it. If at all it's not true, we need to. Okay, whatever I claimed is true. Always verification is better. Now what is happening? We have a, let me do, so 9, 10. I don't need to print the old one, so I need to only, okay, let me keep it for a future use. Real new num list 1. Okay, what do you think here? Is it copying, doing shallow copying or deep copy? Any guess?
Deep copy.
Deep copy. Okay, let me verify it. Sorry. Okay, so 789, I don't know why did I put, my numbering is wrong. Okay, let us run it. The real new num list is same as our num list, no issues, properly copied, but you can see that they are different. That means it's a new copy, deep copy is done. That means it's not just a reference to the same object, it has copied every element, every object, and then created a new list. Now when we say that it is there, both of them are new lists, do not assume that even these elements or multiple copies are there. Actually the content of this two lists will be the same. Okay, these pointers, all these are happens to be integers, they are all integer objects, the same integer copies are there. Only thing is you have created a new list object with the same values. Okay, another copy. Now what is the advantage of having this deep copy? You can modify individually, and then they will be different copies of them will be, and you will be changing it, different copies. Okay, so let me say new num list of 100 equal to, let me say that some 222, and then just for a verification, I need to change it to new num list. Okay, what is the problem? 1. Okay, I'll say 222 111. Okay, now let us print it again. Oh sorry, I shouldn't have printed this. I wanted actually list. Yeah, so they are different. I don't need a parenthesis here, unnecessary. Okay, this is clear, I hope so. Now suppose if you want to really use a library, there is one import copy. Okay, you can also do that. It has got a deep copy function. So deep copy list equal to copy deep copy real new num. Let me take the new one. Okay, deep copy of list 1, whatever you call it as. So let me print it. Okay, I need to print the IDs only, that it is really doing the job. Content will be same, 14, 15. What I am doing, I am doing this. Okay, it is there. I have to copy this guy. Okay, so we need to see whether it is different. Yeah, it is different. So you can see that they are all different from other things also. Here you see this is same as this. Okay, yeah, same object. Okay, real new list. Okay, fine. So deep copy also you can do to do the same job. Anything else I need to show you? That's all. Sublist, how do you create it? Maybe sublist, very simple. You can do the slicing. Our old friend num list will take. I want to take only the first five elements. Now, okay, this we can copy. So this is the num list. We are taking the first 5 elements, sublist. So it's very simple. Now finally, before we exhaust all the list things, we have to remove something. Suppose there are 2 ways you can do it. del num list, I want to delete the first element. Okay, so (17). So first element is 111, which is removed, which is here. And there is one more way of deleting it. Another way of removing an element. You are to call it with respect to the remove. This is item based. Okay. Now, what is the num list has? It has 100. So I want to remove the element 100. So 100 is removed. Okay. So that's another way of removing an element. So now you know appending, sublisting, creating a list, appending, adding, as well as indexing, inserting it into it. Everything is done. Okay. So these are all done. Now let us. Any questions so far? Okay. Now we have almost 30. So I think we can quickly see now. Comprehension. We have interesting part. Comprehension is a very interesting feature. A compact way to create a list. Okay. A comprehension is build that list by applying an expression to each element in a sequence. Now, what I mean by that, maybe you will understand it once I show you the code. You can also, you are creating. Your job is to, it is very difficult when in the data science, when you want to hundreds of thousands of millions of data items have to be created for testing purposes or even for your job. If you keep writing or writing into a file, and then even writing into the file is a difficult job, right? So how do you generate this data? Okay, so the comprehension gives you a shortcut way of generating data. We can have some different logics and some other different expressions to generate them. Now you may be interested in creating a list of list, or maybe list internal inside the list. Then how do you do it? Okay, that's also possible. Now let me show you some examples. Okay, now what is this? You are creating a list of some values which are powers of 2. Okay, that's the expression. Now how many elements are you creating? Now this is a new one. I have not introduced it earlier. Range is a generator. Okay, it has got another element also. It's a step similar to slicing, but now it's a default to 0. Default to 1. And inclusive, exclusive. So it is generating a sequence. Okay, a sequence 1, 2, 3, 4, 5, because it is exclusive. This is inclusive. Okay, so range is a generator function. It's a built-in function. Generates these numbers 1 to 5 in the order, same order, and it assigns to x. So x will take 1 first, then 2, 3, 4, 5. Now this for loop itself is within the square bracket. That means you are creating a list first and then going to add elements to it. What are the elements are you going to add and how many? That's how many is decided by this range function. There are 5 elements, so you are going to have maybe 2 more elements. Now what are the values? That values are these values based on this x what you are getting from the range. So 1 to the power 2, 2 to the power 2, 3 to the power 2, 4 and 5. These are the numbers which will go into this list. So finally that list object reference is passed to this label. So you can see you don't need to put a for loop and then assign it to append it. You don't have to do a append, right? That is a laborious job in terms of number of lines of code, as well as it will take more time. So this comprehension avoids all the headache and then gives you a compressed way of generating list with different values using this for loop business inside the list itself. Okay, so in the first go it will look very complicated, but once you get used to this, you will start writing yourself very easily. This kind of comprehension you can write. Now what about this? Now you know very well what to expect. Okay, power of 3. Okay, so these are the values. It will generate 0, 1, 2, 3. Okay, yeah, but n is here. Okay, it's not here. Okay, what you are generating n is in the top. So 3 power 0, 3 power 1, 3 power 2, 3 power 3. That's what you are getting. I thought 0 power something should have been 0. Okay, so you can keep it. This expression can be anything. Okay, so there are some innovative ways you can actually generate different sequences. Now even x to the power 2 or whatever. No, I don't know why did I name it like this. Yeah, x power of 2. Okay, now let us understand here. You are generating x. Okay, I am taking this list. Okay, this is this list. Okay, x power of power 2, this list. I am picking up each values, and then if mod of that equal to 0, that means it's a even number, right? Yeah, so I will be picking up this. In that case, I will do 3 power n. Now, where is the n coming? There is something wrong. I have not defined n. Okay, n may be already defined on the top. I should have given the value. So based on the result, I need to change it because n I have not put here. Okay, let me see. Now, what should the n value should be? I think there is something wrong here. I think I should put n equal to 1. Okay, can you guys tell me what is the correction I should make? I will do it. To generate this 4 and 16, what should be the value here? Or is this correct?
X.
Sorry?
Sir, only X.
That's all, right? Yes, that's what. I don't know why I made a mistake. Oh, maybe copy paste error. Okay. Good that I caught it now. Is it correct? I think so. Yeah, X is from this list. So 4 and 16, and that's what I am getting it. So for X is X power 2. Maybe you can guys try it out. N is not there at all. Now, how do you flatten a list? Now, suppose if you have a list of lists like this, how do you flatten it? Do you want to try it? Actually, I showed it when the screen was down. So let me show you here. We have to pick up from the list every element. Okay. So when you pick it up in a list of list, what is happening is you are keeping another list, right? So you will have a list object here, list object, another list object. This list will have only 3 elements. Okay, it will have only 3 elements, of all of them being a list objects, and this X will be a list object. So you pick this list object and then do another for to get the element in them. So this is a list object, this is the element, that is you are picking up 1, 2, 3, 4, 5, 6 individually on every iteration, and then you are forming a list with the value Y. So you get this, you are extracting these values and then adding it to the original, the new list. Do you get it? I hope you are able to follow. So let me explain once again. Very simple. We are taking the list of list. So this, you have to understand it that this is executing in this way. Okay. It knows that this value has to be computed, which will be computed by executing this for loops. This is the outer loop, this is the inner loop. The outer loop for gets the individual list objects. There are 3 of them. So this will go for 3 iterations. Inside it there will be 2 iterations, and on every list object you pick up the 2 elements which are there, and then each of those values are added individually to this. There is no comma or something, but it is implicit that on every iteration a new element is getting added, it's appended. So you get to see this. Now I have a question for you. Can I use the same code for any number of sublists inside them? Okay, list objects, any number of list objects, and each of those list objects having any number of items in it. Do you understand? Can I use the same code to flatten another list which has 2, 5, 3, 1? Can I flatten it using the same code?
Yes, sir.
Okay, very good. Now what about this?
No, sir.
It will do, but it will create 2D array.
It will do.
Not flattened.
Yeah, it will not flatten it, but it will create a 2D array, because it will do this object and then put this as one element, and then it will take this an individual element. So what you get will be this 2, 3, and then 3, and whatever I put 4. Correct? Okay. So I think it is very easy now for you. So let me now another examples. If I want to do this, suppose this is the input. Okay, I want to create this. What logic needs to be put? Okay, you know that each element is doing something I am doing. Okay, can you see what I am doing here? Okay,
So,
let me.
so we are finding the transpose.
Transpose, sir.
Yeah, you are doing a transpose. So can you have a logic for this? Maybe I will explain it with an example here. See here. First, this new matrix is having another list inside. So I need to have one list here, another sub list inside. Okay. Now this is how many sublists are there? 3 are there. So I need to have some generator which gives me 3 iterations. Okay, 0, 1, 2. Okay, 3 iterations. This will take care of 3 iterations. So in this case, what happens is it will go from outermost list to the innermost list. It will keep on going in. So it goes to the outer list, and then based on the range what you generate, that many inner lists are generated. So I have that many in a list generated. Now, what are the values that I need to put in is decided by this for loop, which runs on for every list. For every list, it is going to be running. Now, this one is taking the matrix as an input and then creating a row. So it is going to have every individual rows, the complete list it is going to have. Okay, and then it is going to use I for I is 0 to 1. So it is going to keep, is it doing that? Wait a minute. Row of I. So it is going to dereference it with one of the element. Okay. So it is going to pick 1 from here, 2 from here, and 4 from here, because I is 0 to start with. So every row it is going to take this and then pick the first element and then create it. Okay, 1, 4, 7. And then for the next element, it is going to pick 4, 5, and 6. So this is how the transpose is done. And creating a transpose is using a comprehend. Maybe I should change this to a transpose to be clear. Okay, let me write it as transpose, which I missed it out. I hope the logic is clear. Okay, creating a transpose using this logic, using comprehension. And then I want to create this list at all. Okay, just this list. I'm sure you guys can quickly come up with this. Anyway, I will show you. Okay, suppose if I want to create a list like this, what you need to do is this. I want a list. How many elements I want? 4. So keep that generator here. Now the values that I'm filling in is not based on any index generated. This index is not used, but it is used for that many number of sublists to be created. So that's why this range is required and this for loop is required, but we are not using it. Okay, we have a freedom either to use it or throw it. So we are not using that row. And then internally I am running another for loop based on number of elements I need in each of those lists I am creating, which happens to be 3. And I am also not using this column. I am filling it with the same value. So I am doing this. Okay. So this is another way of generating a list like this. So you can in fact use this comprehension for multi-level creation also. Okay. And start exploring and then finding out how which other things are working, what not working. But only thing you need to take care, if you are independently doing it, do not side effect should not be there. That means you should not be changing this row or column internally, any of them. Okay, then you will be disturbing the flow. And also you should remember that which is coming first. This is coming first and then the next this is happening. And the value is either you can use it with the value of row and column, generate it, or you can decide to have something independent of it. Or if you want to fill it up with 1, 2, 3, 4, 5, that also you can do by initializing some value equal to maybe 1 and then incrementing it every time internally, so that you can do it. Okay, which is not dependent on column or row, but this value gets incremented every time. So you can explore many things using these features. These are very vast features. Now suppose if I want to convert a degree into radian, I can have a function I can invoke. Okay, a function which assume that we have implemented it. I can invoke a function and then pass the degree values that I am getting from this list into it and generate the radian and form another list using a radian. So you can even call a function within this comprehension. So this is a very powerful feature that Python has, which you can express it in a very short form and very powerful. Okay, so you can do that. Okay, and actually I have defined the function also. I hope it is correct. Okay, so this is what is a comprehension. Okay, so now I have not given, we are only 10 minutes we have. So what is the next class you have? Do you have immediately your class? I need to give you 5 minutes. Sorry.
Yes, sir.
Oh, okay, you have a class immediately following, so I should not take your time. Okay, so what I will do, okay, I want to ask you your choice. Should I run this comprehension, because I already explained you with the list? I can show you the code and run it once. I'm sure you guys are smart enough to uh, do it yourself. So let me show you what I want to actually done it. It's very simple. Okay, I cannot claim myself. It's very simple unless you tell me. Okay, so no problem. I will just quickly show you the code, run it. Okay, this is what I have done. Rest of it is, these are all very simple, very far range, and then this exactly whatever I showed you in detail. So what I am doing here is, I want to generate a matrix of this type. What do I do? Okay, different ways of doing it from the input matrix. This, okay. So I am sure you can figure it out. Okay, it's a good exercise to figure it out. Okay, I don't want to explain every detail, because I'm sure you can do it. But if tomorrow, always you can ask me. Okay, no problem. I am sure you will be able to do that. Okay, so let me give you what is the homework. I have a plan. Okay, define a list with the different elements as shown below. Okay, something like this, some integers and some function. Okay, function is the same function. Def foo is called with num. Okay, I am passing a parameter to it, and then it prints the value of what number it got. Now what I want you to do is run through, you write a function call f1 from the list, my list. Okay, this is what you are supposed to implement. Another function which is given a list with a mix of integers and a function objects. The function object happens to be only one function of type, but it can have different number of elements can be there, and always this function object is have a prefix in integer always. Okay, it's not that a foo followed by foo is not there. You can assume that it is taken care of. In that case, what I want you to do is call this wherever this function objects are there, and then get the previous integer value. You can always put a logic that if it is not outside the limit, or if it is not an integer object, don't call it. All that you can do, but just to simplify this implementation, I am not expecting you to do that, but you are free to do it. Some of you are very well versed in Python. So I want you to call with these values, the highlighted blue, whatever blue or uh, some color. Okay, blue is, I think, and then it should print like this. Okay, so but don't restrict to only this value. I want you to try it out with multiple entries, and you should work. Okay, I want you to implement this function which is defined here. Okay, this is one homework. I will, as I told you, I will create an entry for this to submit. Now another one, I want you to fill a matrix with all integer values. Okay, um, you can assume that the depth is not too many, it's only one depth. Okay, what are the list? This is the list. Okay, I want you to generate one example I have given you, but you can the same level you can do it. Let me explain here. See, we have one list followed by, this is a complete list. So either one individual list will be there, or a list which contain another list. Okay, only two levels, not more than that. Okay, I'm not having one like this or one more like this. I'm not going multi-level. I'm going only two levels. Okay, one list is there, which will have either a list object, a pure list object, or a list containing another set of list. Okay, that's all. One more level. That's all. Okay, here also you can see this is the outermost list. It may have a list object. Okay, internally it may have a list of list. This is also list of list. This also this is matching with this, so list of list. Okay, it has a list inside a list. Okay, similarly this has a list inside a list, because only 2 is there and then the adjacent this is there. It may be confusing, but every list has one more list inside. That's all, either one or many. Only 2 levels. Now I can have any kind of combinations. Okay, I can have not only this list, I can have any number of them like this, but I need to have an increasing number of numbers, integers filled into them. Okay, but only 2 numbers. I am not expecting you to fill more numbers. Only 2 numbers in each list, but they should be in the increasing order. Okay, I can have any number. I can just copy paste this and then add one more, but still your code should work. Okay, I want you to create a matrix like this. That's a homework. I will end it now. I think I should not exceed my limit. Any doubt you have on this homework? 1 minute you have. I will not take more than 1 minute. You guys have a class. I don't want to come on the way. Okay, time done. Bye bye. See you tomorrow. Good night.
Thank you, sir.
Thank you.
Sir.
Bye bye.
Bye. Thank you. Good night.
Thank
Thank you, sir.
Thank you.